All right. So Joe has 2 boxes of candy. Each box has the same number of candies in it. He also has 4 pieces of candy outside the boxes. We know that Joe has 10 pieces of candy altogether. How many pieces of candy are in each box? So that's the problem. So in order to solve it, I want you to write or draw something that shows what Joe has and that altogether he has 10 candies. Then solve it. Find out how many candies he has in each box. Just talk me through what you're gonna do there. So what are your initial thoughts?
Wouldn't it be like how much he has altogether? No.
What do you mean?
How much candy he has.
So would it help if you drew something out there to help you? So if you think about Joe has 2 boxes of candy. Have you ever seen a box of candy?
Yes.
What does a box of candy look like?
It's a box.
All right.
Filled with candy.
All right. So you can draw anything to
Just
kind of
a
show
random
what's
box.
happening.
So a box.
Sure. It's up to you. All right. So if we read it again, it says Joe has 2 boxes of candies. Each box has the same number of candies in it. So he's got 2 boxes of candies.
Oh.
All right. And then he also has 4 pieces that are outside the boxes. Right, and then he has a total of 10 pieces of candy. So how would you represent a total of 2 pieces of candy? So what are you thinking? So do you know how many pieces of candy he has inside the box?
If he has altogether 10, then
Okay. So that idea of altogether, how would you represent altogether? Let's think mathematically. You're going to create an equation. How do we represent altogether?
you would. You have to divide or
Okay. What do you say divide?
divide 10 by I think how many boxes or how many pieces of candy he has outside.
Okay. So you're thinking if you divided the 10 by the number of boxes or the number of candies he has on the outside, that would give you, what would that give you? So what are you trying to find, in other words?
How much candy he has. How much candy is in each box?
Okay, so you're looking for how much candy he has in each box. So in algebra, how do we represent that unknown? And it's okay. You could even use this drawing if you want. And
when you have 3 pieces in each box.
Okay, why do you think he's gonna have 3 pieces in each
Because
box?
if there's 10 pieces, there's 4 already outside.
Yeah.
And then you just add 3 in each box.
Okay. So can you show me what you just did? How did you get to 3 in each box? You said you had a total of 10 pieces. You had 4 on the outside. So where did you come up with 3?
And then I just started adding random numbers from each box until I finally got to 10 pieces.
Okay. So if you were to write this as an algebraic equation, how could you possibly depict what you just said in an algebraic equation? Or using symbols like plus, minus, equals, any of that stuff, operational symbols. Can you look at this and kind of think about what you just said, what you've drawn here? Could you use any operational symbols?
Yes.
Okay. So what operations do you think you would use there?
You would use.
How about this? Think of it this way. Let's take what you said before. And you said you started with 10. And then how did you deal with the 4? Because that's what it sounded like when you said, I started with 10, then there was 4 on the outside. How did you deal with that to figure out the 3 and 3? Now, I'm not saying you're wrong.
No, it's just confusing because I've never done.
Okay, walk me through the 3 and 3 and 4 and 10. How did you get to that? What operation did you use? Between the 3, and the 4. What did you do to those values to get to 10?
You add them.
Okay. So if you look at this drawing right here, where could you put an addition symbol or symbols in between what?
The 2 boxes.
Okay, so go ahead and do that. Is that the only place that you would put a plus sign?
When you put them in between the box and the.
Okay, yeah, go ahead. And then
an equal sign.
Okay, where would you put the equal sign?
After the 4 pieces of candy.
And then what would be on the other side of that?
The 10.
Okay. All right, now you've got box plus 4 candies equals 10. Now, can you turn this representation into a mathematical representation?
Yes.
Using, what would you use for mathematical representation for the 4 candies?
Order of operations.
Well, I mean,
no.
Sorry. What symbol would you use to represent 4 candies on the outside?
Number 4, no.
Sure.
So where would I put it?
Good question. So look at this equation right here, because you just created an equation, right, with symbols. These are just symbols, right?
Yeah.
So where would the 4
Underneath.
go? Okay. All right. So let's carry our idea of box and box down to here, to this new equation.
So I put 3 and 3.
You could, but let's stick with the boxes, so you can maintain the box idea there.
Bring down these 2.
Sure. We'll do one step at a time. And then what did you have?
Equals 10.
Okay. All right. Okay. So now you've represented those 4 on the outside with the number 4. All right. Now you didn't know what was inside of either of these, right?
No.
How could you represent that without knowing that there were 3 and 3? How could you represent these boxes in algebra? Unknowns.
A number.
Okay.
Or
what do we use to represent number?
I just don't remember the name of it.
Just show me the symbol that you would use. What would you use for an algebraic symbol to represent an unknown?
An X.
Okay. So which one of these would be X's?
The 2 boxes.
Okay. Go ahead and rewrite the equation underneath. Great. Okay. Now how would you get x plus 4 equals 10.
Would you divide Or
What do you notice about these two?
they're the same.
Okay. What do we call those? It's okay. What can you do with x and x?
Add them together.
To make what?
2x.
Okay.
So then I put 2x underneath.
Okay. All right. Is there any way to solve that you know about?
Distributive property first.
Do you have the distributive property there?
4 and 10.
So what identifies
no,
the distributive?
no.
What identifies the distributive property? What do you have to look for when you think about it?
Parentheses.
Do you have parentheses here?
No.
Okay.
Simplify, and then I'd have to simplify.
Okay. So how would you simplify this equation?
-4.
Okay.
For each. 10.
Okay. All right.
That'd just leave me with 2x, and then 2x equals 6.
Okay. Okay. Now what?
Then we would isolate them,
Okay. Isolate what?
the 2x and the 6.
Okay. So what are you trying to get alone? What are you trying to isolate?
6.
Trying to isolate the 6?
No. The x. 2x.
Okay. So you're trying to isolate the x or the 2x?
The x.
Okay. Show me how to isolate the x.
You divide
Okay.
by when you divide by 2x, or no, 2.
Okay. All right. Thought you're about to move the x on me there. All right. So what would be your answer there? How would your final?
X equals 3.
Okay. Is that what you thought it was going to be?
Yes.
Okay. So how do you find out if you get the right answer there?
You would check.
Okay. So if you use this, where would you put that number up here in this one?
Right here.
Okay. So where would the 3 go?
Inside the box.
Just one of them?
Inside both of them.
Okay. All right. So then you'd have 3 plus 3 plus,
4.
does that equal 10?
Yes.
Good job.